So I'm going to talk about how to get started developing on the Safe Network. So my apologies to previous speakers, because my idea is to show that it's very simple and you don't really need to understand all the things that they've been explaining. So I'm going to try to go over all the tools and resources we already have, and they are available for developers, even for users, to learn and understand where to start when they want to create applications for the network. As today was introduced, the App Hub is going to be the main entry point. It should be the main entry point for developers, where you're going to be able to find tutorials and different type of documentation to understand concepts. So we have some sections. Like at the beginning, you're going to find information to understand which are the benefits about developing applications on the Safe Network as compared to developing for the current internet, as well as for users, why they would prefer, or they should prefer, using applications on the Safe Network rather than on the current internet. And then depending on the type of interest, like if you want to develop apps, we have a section to understand what does that mean, where are the main concepts, and then we have tutorials. So at the moment, we already prepared 2 tutorials, which are a step-by-step guide to create your first safe application in less than 20 minutes or so. One tutorial is for creating desktop applications using Node.js and Electron, and the other one is to create your first web app. In both cases, they use boilerplates that we are also just releasing now. So you shouldn't worry about creating the skeleton of the app and all the things that you need to then start looking at the APIs themselves. So with these boilerplates, you can just start coding the APIs code and try to understand how the application really interact with the network. Then you can obviously go deeper and understand how the boilerplates do that for you and all that kind of things. There is another section which is intended to be with more details about the core concept if you want to do some core development and start to be contributing code to the code base of the network itself. And finally, there is a discover section where there's concepts and explains the features of the network, not just for developers, but also for users, about the Authenticator, vaults, the default containers that the network, the accounts has by default, about the different data types that are supported by the network, and so on. So this is also a nice section to start looking at, to understand the features, the main features for users and developers. Then, as we know, the browser is the way to access all the safe site or websites on the Safe Network, and it provides not just that kind of capability, but also you can store bookmarks and your browsing history in your own account securely onto the network, rather than storing locally as all the browsers do at the moment, right? And then one of the main features the browser has is the web API. So the web API is exposed as part of the DOM. So the web apps basically access the Safe Network API using these functions in the DOM to be able to connect to the network and to interact with the Authenticator. And the browser also has some features about like working locally with mock routing or using the local host if you are testing and developing, debugging your app. You don't really need to connect to the actual network to do that. I'm going to mention about the different type of networks shortly. And then we have the Authenticator, which, as we know, is the one in charge of allow you to create account, log in, manage your apps and the permissions, revoke them. As Krishna mentioned before, we want to work on giving more granularity to the user, like for the permissions. Yeah, and it also provides some account information. At the moment, the only account information you can find is about the number of mutations you already made and the ones you are already, the remaining number of mutations you can do for your account. But in the future, we can start showing more information about the account itself. So as a summary of what the authorization of apps means, what's the flow? The first step is an application needs to get authorization by the user to be able to connect to the network. As we know, the data belongs to the user and they don't really belong to the apps. So that's why they need to first send an authorization request to the user through the Authenticator. That's why we go with an authorization request to the Authenticator, and the Authenticator basically just reads that information which identify the apps and show it to the user to say, well, you know, this app wants to connect to the network and it wants permissions for this and these containers and so on. When the user allows that authorization request, the Authenticator will create credentials specific for the application, and it will store it on the network. And at that point, it can return to the app itself these same credentials, so it can then connect directly to the network as in the last step. So from that moment on, the application doesn't really need the Authenticator. It can just connect to the network and communicate directly with the network. You don't need the browser or the Authenticator to be running from that moment on. Maybe something to mention is like the authorization request contains just minimal information about the app itself, so it can be identified by the user. And in the response is just the credentials and the list of permission that the user effectively granted to it. So that's for the app. So if maybe the app wants to make sure that it received the permissions that it was expecting to before proceeding and connecting, or maybe the app decides to notify the user that those permissions are not enough to keep moving, so maybe it's going to stop and it's not going to launch the app and so on. So now I'm gonna go look what I'm calling the Dev Toolkit, which is just the set of tools which are applications and features actually by the network itself that help us in the process of developing applications. The first thing is that we have 3 different types of networks, really. So you can use our test networks, publicly available. At the moment, we have Alpha 2 network available for already 7 months, I think, running. So when you're developing an app, you can use that public test net and have your app to connect directly to it. But if you don't want to, face the limitation of the number of transactions or the mutations you can do on it, you can opt in for mock routing, which is the browser, the Authenticator, and your app will use just a local file to store all the data, and that acts as the network. It's just mimicking the network, and it's transparent to the application. The application works as if it was working with the actual testnet. The API doesn't change, nothing changed, so you can test, debug everything all locally, even offline if you want. And lastly, you can also, if you want to run all the vaults, several instances of vaults on your local machine and create your own local safe network, then you can also connect them with the browser and your app locally to that network that you created. We have some tutorials on our dev forum for how to do that. I tried it myself, and it's really easy. Then we have the Web API Playground tool, which is just a web app which allows you to try some snippets that it already provides. For each of the functions in the Web API, you're going to find a snippet code there that you can run it, or you can modify, you can copy and paste your own code and test basically all the code of your application that needs to use the API before then you actually put it on your app. So this is really cool application, and you can also run it from the local host, or if you wanna publish on any of the test networks, you can do as well. And also this web hosting manager, I think many people know it, but basically just the way to publish websites on the network. And and also it allows you to manage your public IDs. I'm gonna explain a bit about what public IDs are in a moment. So with this application, you after you build your app, your web app, you just can upload all the files, publish it on the network, and then you go to the browser. You are able to load the app. And well, the boilerplates, which are the new set of tools that we have now. As I said, at the moment we have two type of boilerplates, one for Node.js and the other one for web apps. And then they are the way that we prepare the tutorial is that you are not just introduced to the API, but also to some of the concepts of the data types, like mutable data, and how you interact with the entries in the mutable data, and so on. So for the Safe API, I'm gonna try to just explain the main areas, just so you can understand what kind of things you can do with the API functions. Before that, just to give a context, I'm not gonna go in details, but just to give a context so you understand how all the different components fit together on the client side. So all the blue boxes at the bottom are what are part of the Safe Client libraries, and those are the ones that are really connect to the network and provides an abstraction layer for accessing the different data types or doing all the things that we need for the authenticator and so on. And then we use the FFI layer exposed by it to create our bindings. As we talked before, we have the Node.js binding. We are trying to finalize the one for C#, Java. We know that people from the community working on Python binding, and we also have a C header, so you can also create your C applications and bind them with the Safe Client libs, link them with the Safe Client libs. And then applications just use these bindings using the programming languages as they would do with any other library, really, any other package available out there. Then we have the browser, which contains, on one side, it's the Authenticator piece, which connects directly to the Authenticator library through the FFI. This is, as you know, like to provide all the account management and all these type of things you see in the UI. And then we have the Web API that is just a wrapper of the Node.js API. We are now working on trying to make them more similar, so you don't really need to change your code if you want to move from a Node.js API or Node.js app, to a web app. And we are trying to get rid of the handles. If some people here were already developing web apps, they know that they are not really nice, so we are trying to get rid of that. So an app and a web app just makes use of that web API through the DOM exposed in the browser itself. And yeah, lastly, Rust applications don't really need to access through the FFI. They can just use the SafeWork or the Safe App library directly, because they are also built on Rust. So some general concepts. Every account on the Safe network has, when it's created, it has a default set of containers. These are meant for applications to store different type of files. The same way you have it in other operating system or devices that you would store music files. You would store them on the music container. And then the apps can also request the user for having its own container. And this container is meant to be only for very specific things that the app needs to store, like configuration, options, preferences that the user is allowed to set on the app, that kind of things. So all these containers, the permissions for these containers are part of the authorization request the app sends at the beginning. That's what the user really needs to check if it's going to allow the app to, certain permission on this type of containers. Then we have the concept of what we call public ID. So in the current internet, to publish like a website, for example, you need to register a domain name, and then that's where you're gonna host your application and have the DNS system to point to your host server to find your files of the web site. But in the safe network, we just use what would be the domain name. We just get a hash of that string, and that output is what we use as the location for all the files on the network. So whenever you type my app, we just get the hash of it, and we go to that location on the network to read all the files for that website. So that's what we call public IDs, and that's how you find websites or content by using a domain name or a string or something human readable. And the last thing is services containers. So a public ID can be mapped to more than one service. So you could have many websites in a similar way to subdomains in the current internet. You could have service1.myapp or service2.myapp. So every public ID is mapped to a container which has all the services listed, and each of them is mapped in turn to another container where the files for that service is stored. Like maybe it's a website, but maybe it could be any other type of service, like an email. So the service for the email will be mapping to a container where you can find the inbox, the public encryption key to encrypt the messages before storing them on the inbox, and so on. So I'm gonna go like at a high level the main areas. The simplest one is the web fetch function that we have, which is just to allow apps to retrieve websites by using the public ID and service name. And it also supports content streaming using the range headers as it was used by some of the video players already. Then we have all the functions related to access the default containers that I was just talking about, and being able to retrieve them by name, and also verify which is the set of permissions that the user has granted to the app for those containers. And this also, if the app requested its own container, it can also retrieve it with this type of functions exposed in the API. And then we have a set of functions to generate the authorization request. So the app just needs to provide its identifier, and the authorization request can be generated. And in the same way, you can also read which were the permissions granted when you get the response from the authenticator. And also there are two ways that an app can connect to the network. One is basically a registered connection, which is after the user authorizes the app, it can connect, and it has permissions to act on the user's data and do mutations and so on. But it can also connect in what we call unregistered way, which is like a read-only mode, and it will be able to read only unencrypted and public data. And this is exactly how the browser is able to fetch websites. It creates an unregistered connection, and it can just read public websites which are unencrypted. And there is some mock login or fake login functions that you can also use to to develop apps or debug the apps. Then we have the two main data types: mutable data and immutable data. So for the mutable data, there is a set of functions that you use to create them. We have two types of mutable data: it's public or private. Public is just plain and unencrypted, and private, on the other hand, is basically it contains some encryption keys, so entries can be encrypted. And you can actually have some of the entries not encrypted and some of them encrypted. And also you can decide if you want this mutable data be created in a random location on the network, or if you want them to be created at the specific location that you provide. And then we have all the utilities to be able to iterate through the entries, mutate them, and encrypt the entries. Now, for doing mutations, you obviously need to have permissions. So the mutable data has a set of permissions, and you can also manage those permissions through the API. And you can also request permission for those permissions for those type of actions, which is inserting, updating, or deleting entries, or even permission for actually managing the permissions themselves. On the immutable data it uses the self-encryption algorithm. This is stored on the network, is immutable. So if we have functions to be able to create them. So the self-encryption is all done by the libraries. It's not something you need to worry about. And you can actually store also unencrypted immutable data or encrypted immutable data. And if you're going to encrypt them, you can also use symmetric or asymmetric encryption mechanisms, depending on what you are aiming at. And also you are able to read partial content from this immutable data. And this is how we are able to support the streaming, content streaming from the web fetch, because basically we use the immutable data partial content functionality. Then we have what is the NFS emulation. So in any mutable data that you create, either private or public, you can then access it through an NFS emulation. Instead of like seeing it as it is actually a key value store, you can see it as an NFS folder, right? So we have functions that you can use to create, insert files, delete files, and you can also have this read, write, and append modes on the files. It's all an abstraction layer provided, but underneath is just simply mutable data. So there is no really a hierarchy, but it's emulated by using the full path of the files. So the application, if it wants to show the user the hierarchy, it actually needs to do it itself, as they are stored just using the path of each of the files. And there are a set of crypto utilities, that is to generate signed and encryption key pairs, or use to encrypt, decrypt content, sign, verify signatures, all that kind of things, and some hashing utilities. This is the main purpose of providing these functionalities, to prevent apps to add some additional dependencies, as the libraries, the safe client libraries are already using this, so they just expose them, and apps can also get the benefits of having them at hand without having all the dependencies. And we have a few functions that you can use to check the network connectivity state. You can get notifications in the way of callbacks when there is a disconnection event to the network. So apps can act upon that and maybe ask the user if he wants to reconnect, stop working. It depends on what the app is willing to do with that. But all the utilities are there. And finally, we have some some utilities for the system URI. So now to send and receive this message between the apps and the authenticator, what we use is we register a custom protocol in the system. So these utilities are, allow apps to do it without needing to worry about the platform. Like if it's Windows, OS X, or Linux, they all have different ways of doing registering these custom protocols. So they don't really need to worry about that. In the case of mobile, they actually would use, if they're using the native programming languages, they would use directly that functionality from those libraries rather than this. But for desktop application, like for PCs, this is very useful. And this is what we actually use in our applications like the browser or the web hosting manager. So all that is like a summary of all the tools and resources we have. But I think one of the most important one that needs to be considered by any developer trying to create application is really the community and all the things that where we participate with articles, discussions. We also have several meetups around the globe. So I really would encourage any developer who wants to start developing applications on the Safe Network to go and check out all these resources. In the forums, there is always people willing to help, not just with issues with the code itself, but also trying to understand concepts or how the network works and so on. So this is one of I think, the most important resources we have. And now, as we were talking about, the Dev Hub should also be an important place to go and read about. So with all this, I hope this all helps encourage developers to create applications on the Safe Network, because when you get to know and understand exactly which are the benefits of the Safe Network, like not needing to worry about the infrastructure, scaling strategies, account management system, all these type of things, that's when you realize how convenient it is and how secure it is to create applications on the Safe Network. So I hope this all helps, and I would say that let's play safe, that's safe, and let's do something great. Thank you. Thank you.